This is an audio-visual presentation on SET. Now, let's consider the behavior of the numbers we have here. We have the counting numbers 1, 2, 3, 4, 5, 6, 7 in that order. Now, when we square 1, the result is 1. When we square 2, the result is 4. Squaring 3 gives us 9. Squaring 4 gives us 16. When we square 5, the answer is 25. 6 squared is equal to 36. 7 squared is equal to 49 in that order. Now, 1, 4, 9, 16, 25, 36, and 49 are called perfect squares, since their square roots give whole numbers without remainders. Now, when we take the square root of 1, the answer is 1, and 1 is a whole number without a remainder. Therefore, 1 is a perfect square. When we take the square root of 4, the answer is 2. Square root of 16 is equal to 4. Square root of 25 is equal to 5. Square root of 36 is equal to 6. And the square root of 49 is equal to 7. Now, since the square root of all these numbers are giving us whole numbers without remainders, that is why we say they are perfect squares. So perfect squares are numbers whose square roots give whole numbers as answers without remainders. Now, let's look at these numbers. 7 and 18 are not perfect squares. Therefore, their square roots, root 7 and root 18, are irrational numbers with non-terminating or non-repeating decimals and are generally called sets. Now, let's look at the number 7. When we take the square root of 7 and you take the square root of 18, they give non-terminating or non-repeating decimals, and that is why they are generally called sets. When we say a number is an irrational number, it means that that number cannot be expressed as a quotient of two integers. So root 7 and root 18 are irrational numbers with non-terminating or non-repeating decimals and are generally called sets. That means that when you take the square root of 7, you have a number and a remainder. That is, you have a decimal as an answer. Similarly, when you take the square root of 18, you also have a decimal. So because we are not getting whole numbers, that is why we say root 7 and root 18 are called sets, because they are irrational numbers with non-terminating or non-repeating decimals. Now, root 7 is equal to 2.645751311. In that order, it continues. So we can see that the answer is non-terminating, and that is why root 7 is called a set. This answer cannot be expressed as a quotient of two integers because it's non-terminating decimal. Now, when we consider root 18 is equal to 4.242640687. It continues like that. So because root 18 is a non-terminating decimal, that is why we say root 18 is also called a set. So root 7 and root 18 are examples of sets. Now let's look at how we can simplify a set. Now 6 is equal to 2 times 3. That is when we multiply 2 by 3, the result is 6. So the square root of 6 is equal to the square root of 2 times 3. That is when we take the square root of the left hand side, we also take the square root of the right hand side. And in doing that, we have square root of 6 is equal to square root of 2 times 3. And now the square root of 2 times 3 is equal to the square root of 2 times the square root of 3. Now 20 is also equal to 4 times 5. So when we take the square root of the left hand side, we have the square root of 20. And when we take the square root of the right hand side, we have the square root of 4 times 5. And the square root of 4 times 5 can be expressed as the square root of 4 times the square root of 5. Now the square root of 4 is equal to 2, because 4 is a perfect square. That is why the answer is a whole number without a remainder. So we have 2 times the square root of 5. Now when we take the square root of 5, the answer is a decimal. And so we say that root 5 is a set. We say that root 5 is a set because the answer is a decimal. So 2 times square root of 5 is equal to 2 root 5 is equal to 2 root 5. This is how we simplify a set. Now let's look at this example. Example 1. Simplify the following sets. Simplify the following. I. We have the root of 60. I. Root 45. I. The root of 32. Now we are asked to simplify the following sets. Let's look at how best we can solve this problem. These are all called sets because when we take the square root of 60, the answer is decimal. When we take the square root of 45, the answer is also decimal. Similarly, when we take the square root of 32, the answer is a decimal. And because the answers does not give us whole numbers, we say they are sets because they cannot be expressed as a quotient of 2 integers. Now let's look at the solution to this problem in example 1. Now solution. I. Square root of 60. How do we simplify the square root of 60? What we are going to do is that we are going to search for 2 numbers. When we multiply those 2 numbers, the results must give us 60 in such a way that one must be a perfect square. So root 60 is equal to the square root of 4 times 15, because when you multiply 4 by 15, you are still getting back your 60. That means that the square root of 60 is equal to the square root of 4 times 15. Now you can see that 4 is a perfect square, and we know that square root of 4 times 15 is equal to the square root of 4 times the square root of 15. Now when we take the square root of 4, the answer is 2, and that is why 4 is a perfect square. And 2 times square root of 15 is equal to 2 root 15. This implies that root 60 is equal to 2 root 15. Now considering the example in II, we are asked to simplify the square root of 45. And so we try to search for 2 numbers, that is factors of 45, in such a way that when we multiply the 2 numbers, we are getting 45. And one must be a perfect square. So 45 can be expressed as 9 times 5. And you can see that 9 is a perfect square. Now, square root of 45 is equal to square root of 9 times 5. And square root of 9 times 5 can also be expressed as the square root of 9 times the square root of 5. Now when we take the square root of 9, the answer is 3. So we have 3 times the square root of 5, and that is 3 root 5. We have 3 root 5. This means that square root of 45 is equal to 3 root 5. Now I square root of 32. So here we also search for two numbers. When we multiply the two numbers, we have to get 32 in such a way that one must be a perfect square. And root 32 is equal to the root of 16 times 2, because when you multiply 16 by 2, you are getting back the 32. That means that the square root of 32 is equal to the square root of 16 times 2. Now the square root of 16 times 2 is equal to the square root of 16 times the square root of 2. Because 16 is a perfect square, when you take the square root of 16, the answer is 4, a whole number without a remainder. That is why 16 is a perfect square. So we have 4 times the root of 2, and 4 times the square root of 2 is equal to 4 root 2. This means that square root of 32 is equal to 4 root 2. Now we look at addition and subtraction of sets. Consider below a root b plus c root b. Now we can see that for a root b is a set, and for c root b is also the set. So we can see that they have the same set, and therefore we add the coefficients of the set, that is a and c. So a root b plus c root b is equal to a plus c root b. We can only add their coefficients together if only they carry the same set, root b, root b. That is why we factor root b out and we add the coefficient a plus c. Example, if you have 2 root 3 plus 5 root 3, we can see that they carry the same set, root 3, root 3. So we can add their coefficients, and their coefficients are 2 and 5. So we have 2 plus 5 root 3, and 2 plus 5 is equal to 7. So we have 7 root 3. Now with the subtraction of set, if you have a root b minus c root b, we can see here that we have the same set, root b, and so we subtract the coefficients. So we have a minus c root b, a minus c root b. So you can only subtract the coefficients if they carry the same set. Example, 2 root 3 minus 5 root 3. Because they carry the same set, root 3, it means that we can subtract 5 from 2. And that is how come we have 2 minus 5 in brackets times root 3. And 2 minus 5 is equal to minus 3. So we have minus 3 root 3. Minus 3 root 3. Now let's consider this example. Simplify the following. A. 5 root 3 plus 6 root 3. B. 3 root 11 minus 4 root 11. C. Root 80 plus root 20 minus root 45. That is the square root of 80 plus the square root of 20 minus the square root of 45. Now let's see how best we can simplify this problem. Now we look at the solution. The solution A. Given 5 root 3 plus 6 root 3, we can see here that they carry the same set, that is root 3, and therefore we can add the coefficients, and the coefficients are 5 and 6. So 5 root 3 plus 6 root 3 is equal to 5 plus 6 root 3, and 5 plus 6 is equal to 11. So we have 11 root 3. This means that 5 root 3 plus 6 root 3 is equal to 11 root 3. That is, when they carry the same set, you can add the coefficients. If they carry the same set, you can add the coefficients. Now B, 3 root 11 minus 4 root 11. Here we can also see that they carry the same set. Root 11 here, we have root 11 here. And so we can subtract the coefficients. And the coefficients are 3 and 4. Now because we are subtracting, this means that we are going to have 3 minus 4 root 11. That is 3 minus 4 root 11. And 3 minus 4 equals minus 1. So we have minus 1 root 11. And it's equal to minus root 11. This means that 3 root 11 minus 4 root 11 is equal to minus root 11. Now C, square root of 80 plus square root of 20 minus the square root of 45. Now with the number 80, we search for two numbers. When we multiply, we get 80 in such a way that 1 must be a perfect square, and 80 is the same as 16 times 5. And so you can see that 16 is a perfect square. Now 20 can also be expressed as 4 times 5, and 4 is the perfect square. 45 can also be expressed as 9 times 5, and 9 is the perfect square. Now the square root of 16 times 5 is equal to the square root of 16 times the square root of 5 plus the square root of 4 times 5 is also equal to the square root of 4 times the square root of 5 minus the square root of 9 times 5 can be expressed as the square root of 9 times the square root of 5. Now because 16 is a perfect square, when we take the square root of 16, the answer is 4. So we have 4 times root 5. 4 is also a perfect square. So when we take the square root of 4, the answer is 2. So you have 2 root 5. Now the square root of 9 is also 3. So you have 3 times root 5. Now 4 times root 5 is 4 root 5. Plus 2 times root 5 is 2 root 5. Minus 3 times root 5 is 3 root 5. Now we can see that they carry the same set, and therefore we can add and subtract the coefficients. So 4 root 5 plus 2 root 5 minus 3 root 5 is equal to 4 plus 2 minus 3 into bracket root 5. That is because they carry the same set, root 5. You can factor root 5 out, and in bracket we have 4 plus 2 minus 3. Now 4 plus 2 equals 6, and 6 minus 3 equals 3. So we have 3 root 5, and that is how come we have 3 root 5. Now let's consider example 3. Simplify the square root of 162 plus the square root of 32 minus the square root of 98, all divided by the square root of 8. Now in this case, considering the number 162, we are going to search for two numbers. When we multiply, we will get 162 in such a way that 1 must be a perfect square. Now with the number 32, we also search for two numbers. When we multiply, we get 32 in such a way that 1 must be a perfect square. Now with the number 98, we also search for two numbers. When we multiply, we get 98 in such a way that 1 is a perfect square. And the same thing applies to the number 8. We search for two numbers. When we multiply, we get 8 in such a way that 1 must be a perfect square. Now let's see how best we can solve this problem. Given the square root of 162 plus the square root of 32 minus the square root of 98 divided by the square root of 8. Now 162 is equal to 81 times 2, and 81 is the perfect square. 32 is equal to 16 times 2, and 16 is the perfect square. 98 is equal to 49 times 2, and 49 is the perfect square. And 8 is equal to 4 times 2, and 4 is the perfect square. This means that the square root of 162 plus the square root of 32 minus the square root of 98 divided by the square root of 8 can be simplified as the square root of 81 times 2 plus the square root of 16 times 2 minus the square root of 49 times 2 divided by the square root of 4 times 2. Now, when we take the square root of 81, the answer is 9. So we have 9 root 2. Now, when we take the square root of 16, the answer is 4. And that is how come we have 4 root 2. Minus, when we take the square root of 49, the answer is 7. So we have 7 root 2. All divided by, taking the square root of 4, the answer is 2. So we have 2 root 2. Now, when we consider the numerator, we can see that they carry the same set, root 2, root 2, root 2. That means that we can add and subtract the coefficients. So we have 9 plus 4 minus 7, root 2. And 9 plus 4 equals 13. Now 13 minus 7 equals 6. So we have 6 root 2 divided by 2 root 2. Now when root 2 cancels root 2, we are left with 6 divided by 2. And 6 divided by 2 is equal to 3 because 2 goes into 6 3 times. So the answer is equal to 3. Now let's look at multiplication of set. Now we look at multiplication of set. Square root of a times the square root of a is equal to the square root of a all square. And the 2 cancels the square root and we are left with a. That means that the square root of a times the square root of a is equal to a. So the square root of a number times the square root of the same number is equal to the number. Now let's take note of this. The square root of a times the square root of b, that is when the numbers are not the same, we multiply the numbers under the roots. So the square root of a times the square root of b is equal to the square root of a times b. And this is equal to the square root of ab, because when we multiply a by b, the answer is ab. Now simplify the following. A, root 3 times 3 plus root 2. B, root 3 minus root 2 into bracket 2 root 3 plus root 2. C, root 3 times 2 root 3 plus 2 over root 3. Now let's look at the solution. Solution to the question in A. Root 3 times 3 plus root 2. Root 3 times 3 plus root 2. Now here we are going to expand. So we are going to multiply root 3 by all the numbers in the bracket. And so we have root 3 times 3. And that is root 3 times 3 plus root 3 times root 2. So we have root 3 times root 2. Now the coefficient of the set root 3 is 1. So we multiply 1 by 3. And 1 times 3 is equal to 3. So we have 3 root 3. So we have 3 root 3. Now the square root of 3 times the square root of 2. Because the numbers are not the same, we multiply the numbers under the roots. So we have 3 times 2. And that is 6. That means that the square root of 3 times the square root of 2 is equal to the square root of 6. So we have 3 root 3 plus root 6. Because the sets are different, we can't add the coefficient. Take note that the coefficient of root 6 equals 1. We cannot add the 1 to 3 because the sets are not the same. Here we have root 3 and here we have root 6. Now B. Root 3 minus root 2 times 2 root 3 plus root 2. Now we are going to expand. So root 3 will multiply the second bracket, and minus root 2 will also multiply the second bracket. And in doing that, we have root 3 times 2 root 3 plus root 2 minus root 2 times 2 root 3 plus root 2. Now root 3 times 2 root 3 will be 2 root 3 all square, plus root 3 times root 2 will be equal to root 6. That is 3 times 2 is giving us 6. So root 3 times root 2 is equal to root 6, minus root 2 times 2 root 3. Because coefficient of the set root 2 equals 1, 1 times the 2 will give us 2, and root 2 times root 3 is equal to root 6, minus root 2 times root 2 is root 2 all square. Now root 3 all square, 2 will cancel the root, so we are left with 3. That is how come we have 2 times 3 plus root 6 minus 2 root 6 minus, now root 2 all square will also give us 2, because 2 will cancel the square root and we are left with 2. 2 times 3 is equal to 6, minus our 2 here, so we have 6 minus 2. Now take note that we have root 6 here minus 2 root 6, because they carry the same set. Coefficient of this root 6 is 1, so we can subtract the coefficient. So we have 1 minus 2, and that is minus 1. So we have minus 1 root 6, and minus 1 root 6 is the same as root 6. That is why the 1 cannot be seen. 6 minus 2 is equal to 4, so we have 4 minus root 6. 4 minus root 6. Now see, root 3 times 2 root 3 plus 2 over root 3. Here we multiply root 3 by the numbers in the bracket. So we have root 3 times 2 root 3 plus root 3 times 2 divided by root 3. Now when we multiply root 3 by 2 root 3, coefficient of the set root 3 here is 1. So we multiply the coefficient. So we have 1 times 2, and that is 2. And root 3 times root 3 is root 3 all square, plus root 3 times 2 will give us 2 root 3 divided by root 3. So we have 2 root 3 divided by root 3. Now root 3 all square is equal to 3. And so we have 2 times 3 plus 2, because root 3 will cancel root 3 and we are left with 2. Now when we multiply 2 by 3, the answer is 6. And 6 plus 2 is equal to 8. This means that root 3 times 2 root 3 plus 2 over root 3 is equal to 8. Now let's look at rationalization of the denominator. When we consider this fraction 1 divided by the square root of a, the numerator is 1 and the denominator is root a. So we can see that the denominator is a set. Now 1 divided by root a, to avoid division by decimal, because if root a is a set, that means that the square root of a will give us decimal. And so to avoid division by decimal, we rationalize. And how do we rationalize? We multiply 1 over root a by the set, that's the denominator. So times root a, then we divide by the same root a. Now 1 times root a, so we have 1 times root a divided by root a times root a. Now 1 times root a is equal to root a, and root a times root a equals root a all square. Now when the square cancels the root, we are left with a. So finally we have root a divided by a. So we can see that the denominator is a number. So now we have avoided division by a set. We have now avoided division by a set by the principle of rationalization. Now example, let's rationalize the following. 3 root 2 divided by root 3. 7 root 5 divided by 2 root 7. Root 5 times root 5 plus 3 over 2 root 5. Now let's see how best we can rationalize the following. Now A. 3 root 2 divided by root 3. So when we consider the denominator, our denominator is root 3. That is the set. Now to avoid division by decimal, we rationalize. So we multiply the numerator by the set, that is root 3. Then we divide it by the same set, root 3. Now we have 3 root 2 times root 3. That is 3 root 2 times root 3. All divided by root 3 times root 3. That is how come we have root 3 times root 3 here. Now, coefficient of the set root 3 equals 1. So we multiply 1 by 3. And 3 by 1, that is 3 times 1 is equal to 3. Now square root of 2 times the square root of 3 is equal to the square root of 6. So we have 3 root 6. Square root of 3 times the square root of 3 is equal to the square root of 3 all square. Now when the square cancels the root, you are left with 3. This means that the answer now becomes 3 root 6 divided by 3. Now 3 goes into 3 once, and 1 root 6 is the same as root 6. Therefore, 3 root 2 divided by root 3 is equal to root 6. Now, let's look at the solution in B. 7 root 5 divided by 2 root 7. This is equal to, now to avoid division by a set, because we can see that when we consider the denominator, the set is root 7, because root 7 will give us decimals. So root 7 is the set. Now to avoid division by decimals, we need to rationalize. So we multiply the numerator by the set, root 7. Then we divide by the set, root 7. Now 7 root 5 will multiply root 7. And that is how come we have 7 root 5 times root 7. 2 root 7 will also multiply root 7. And that is how come we have 2 root 7 also times 7. Now coefficient of the set root 7 here is 1. So we multiply 1 by 7. And that will give us 7. Square root of 5 times the square root of 7 will give us the square root of 35. Because when we multiply 5 by 7, the answer is 35. All divided by coefficient of the set root 7 here is 1. So when we multiply 1 by 2, the answer is 2. Now root 7 times root 7 is root 7 all square. And now the 2 will cancel the roots. So we are left with 2 times 7. So this is equal to 7 root 35 divided by 2 times 7. And 2 times 7 is equal to 14. So we have 7 root 35 divided by 14. Now 7 goes into 7 once, but 7 goes into 14 twice. That is how come we have half. Don't forget, we have root 35 here. So the final answer is half root 35. That is 1 over 2 root 35. Now, C. Root 5 times root 5 plus 3 over 2 root 5. We first open the bracket. So we multiply root 5 by all the terms we have in the bracket. So we have root 5 times root 5. That is how come we have root 5 times root 5 here. Plus root 5 times 3 will give us 3 root 5 divided by 2 root 5. So we have 3 root 5 divided by 2 root 5. Now root 5 times root 5 is root 5 all square. Plus 3 root 5 divided by 2 root 5. If you want to rationalize, we have to multiply the numerator by the set, that is root 5, and we divide it by the same set, root 5. Now root 5 all square is equal to 5 plus 3 times root 5 times root 5 is root 5 all square divided by 2 times root 5 times root 5 is root 5 all square. So 2 times root 5 times root 5 will be equal to 2 times root 5 all square. Now when the square cancels the root, we are left with 5. When the square cancels the square root, we are left with 5. And so 3 times 5 will give us 15, and 2 times 5 will give us 10. It's either you multiply 3 by 5 and divide by 2 by 5, or 5 cancels 5 and you are left with 3 over 2. Now 3 over 2 plus 5 will be equal to 13 divided by 2. This is the end of our presentation on set.